Hello everyone, welcome to the MixedRealityToolkit tutorial series. In the last video, we saw about the focus providers and the focus-based events as well as the far pointers. So in this particular section, we are going to deal with near pointers, like how you can interact with objects which are in a closer proximity, and as well as the object manipulation like scaling, rotation, and moving around of the objects. So if you go to the Mixed Reality Toolkit and click on that one, you will be able to see in the input section there are two pointers. Like one is the grab pointer and the poke pointer, right? So they are our near interaction pointers, and they are always attached to the articulated hand, which means every time there is an articulated hand in the scene, the input system will detect that and also create these two pointers, poke pointer and a grab pointer, and attach it to the articulated hand controller, the controller type. So the poke pointer is used for near interaction touch, like a poking, a tapping on a switch or a button or things like that, while a grab pointer is used for actually grabbing and manipulating with one or both hands, with a near interactable object. So we will get to see how we declare a particular object as near interactable or near touchable, right? And also see how these particular poke pointer and grab pointer work. In a sense, the poke pointer, both these work by something called spear casting, right? So let's take a look at the code and see what exactly I'm talking about here. Yeah, here you go. So this is the function which actually looks for the near interactable game objects near our, the finger in this case. So all it does is it uses a function from Unity engine called overlap sphere non-alloc. So basically what it does is that it returns an array with all colliders touching or inside a sphere, which is where this which is where this particular casting is done. The sphere casting is done. And in the case of that is there are two variations. One is the overlap sphere, and then there is the overlap sphere non-alloc. The only difference is that in the non-alloc it computes and put these colliders into a provided buffer, while the other one just gives all those colliders available. So the one that is one of the criteria. Every game object that needs to be near interactable need to have a collider, right? So that it can be put into this particular query buffer after it's being found. The second one is that it needs to have a script called near interaction touchable. So it basically looks for the base near interaction touchable, which is where both the near interaction touchable as well as in the case of Unity UI, the near interaction touchable Unity UI inherits from. So that's the second criteria to declare an object as a near interactable, right? And then the third one is definitely it needs to be in the proper layer mask, which allows the near interaction. If it is a layer mask that needs to be excluded, you can configure it so, and that will be excluded from the scanning process. And the last but not the least, it needs to be within a radius or in the proximity radius to be declared as a near interaction touchable. So it will convert those events like a touch or a click events and erase those events whenever the fingers are nearby. All right, now let's take a look at the grab pointer. Just like the poke pointer, the grab pointer also uses the overlap sphere call from Unity in order to identify the closest game objects, which contains a different script this time called a near interaction grabbable, right? Instead of the near interaction touchable. And another difference is that it does not raise any events like the near interaction touchable. All it does is like it will update in every frame that what are the objects which can be grabbed and manipulated. And that particular function call, which is present in the sphere pointer, is called through the focus provider. Now, don't confuse between the sphere pointer and the grab pointer. The sphere pointer script is the one which powers the grab pointer. And the other scripts like the manipulation handler, which we will see in some soon actually, they will make use of this grab pointer and other poke pointer. It will basically scan through all the pointers available in the scene and find out which objects are manipulatable. Now, if you take a look at the grab pointer, expanding it, you can see that it is basically the spear pointer behind the scenes attached as a script into the grab pointer prefab with all the configurations like the spear casting radius, the radius for the spear used to query for the grabbable objects, and then the layer mask and everything, right? So yeah, these are the two near interaction uh, pointers which you can use for identifying uh, which game objects can be manipulated or touched and interacted with. All right, now what we are going to do is put these, what we just learned, into application and to see the actual application of these pointers by creating interactable objects as well as manipulatable objects, right? So first we are going to see how poke pointer is in action by creating something called a pressable button, right, through by poking on it. So I'm going to create a new material. We are going to use the same cube that we have used in the previous demo, and I'm going to create a new material here and change the color to something appropriate. Maybe a green is fine. And then I'm going to change the standard shader to MixedRealityToolkit standard shader. So you will see what is the difference here. And there is one property that like proximity light that I want to explore. But first we will see without that, and then we will see what happens when these properties are changed. So the first one is a standard shader, and the second one is the MixedRealityToolkit shader. So let's try it out. Let me first readjust it a little bit, and then yeah, keep this red one a little bit to the side so we get a focus on the white one. And yeah, it looks like, yeah, we have a perfect view right up there. If you play, that's another thing I want to remove this because if you notice this, this debug panel is kind of like an obstruction for this particular demo. So I'm going to remove it by going to Mixed Reality Toolkit, disable the diagnostic system so that panel won't be displayed again. Yep. So now we have a good view. So if you look at the pointer here, you can see that it's just a circle pointer which appears on the red one. Now, yeah, and you can also see a tethering. No matter how close my finger gets to and how far it is, you can see a tethering which is attached from my index finger to the cube, right? So this is a standard shader. Now I'm going to apply this the green new shader that we created onto the new object, and you can see it is a mixed reality standard shader, and I've just made it in a light. Now let's play and see. Now you see that that's the difference, right? Now there is a kind of like a halo or a how do I say it, gradient effect when I move my pointer around. So it gives a better cue to the user where they are looking at rather than a very small pointer, right? So it's more evident, be it gaze, be it hand, you can see it on both. Even now, it still has the tethering, right? Even if it is in a close proximity. So that's what we are going to change by modifying one of the property here called the proximity light. Yeah, there you go. Let's take it on. It's still in the play mode. So now if I turned it off. Okay. Yeah. Now, if I come closer, you can see there is a much better pointer, right? A more bright halo effect when I get my fingers get closer to the object. You see that? Yeah, that's basically the proximity light in play, which is a part of the shader. So the first part is done. Now what we are going to do is make this guy a pressable button, right, in the 3D space. So for that, the first thing, as we mentioned before, is to add the script called near interaction touchable. So when you type it, you can see those different kind of scripts. And near interaction touchable Unity UI is for Unity UI based objects. Right, so here we just added the near interaction touchable. Now you can see there are two types of events there, and also few local forward and up and all those things. They are nothing but the vector up, vector forward, those kind of things, which is defined in order to make sure that at all those touch planes need to be adjusted for this particular cube. So I added this script basically when it was in play mode. So now I'm adding it again when the actual scene mode. If you see that now, I can see that bounds are not matching, as well as the center collider options are also not matching. So basically what it's trying to do is, first I'm going to scale it down to, let's say, 0.25 all the way. So it's a proper button and it's small. And now setting up the bounds properly of the script, so that all those planes will properly be adjusted to the actual collider of the object. And those forward, up, and all those things are basically the tilt angles of that the touchable plane. So I'll show it to you right now once we fix this in right now. And there are two events called touchable touch event and also pointer events. So I'll show you. Let's take a look at the code first. There you go. Now, if you look at those vectors and the local forward and everything, they're nothing but the standard vector forward, vector up, and everything. So all it defines is that the angle and the location, the position of those touch plane, right? So let me put it in a proper position, and yeah, you can see that angle changing when I change it. Now when I fix those boundaries, this is it will be more evident. You can see that plane actually. Right now the planes are so small that you're not able to see those planes. That's why you're only able to see those angles changing. Now let me go and fix the bounds first. There you go. Now you can see that plane actually fully formed around the border of the four borders of the cube, and also fixing the center so that the plane will be forward. Now remember that particular pointing normal angle, the white angle pointed out, should always be facing the camera. Now you can see these tilt angles, right? So what happens is, like, now I can touch that plane from a side angle, and that's the normal. I can still touch it straight forward, but when I touch it from the right side, the touch interaction will start happen faster. But on the left side, it will be a bit. I need to push further. So you can play around with that and skew it and change it and all those things, right? And then we need to add that collider as the touchable collider. That's another thing that we need to do. And now I'm going to add the pressable button. So there are two types of pressable button. The one is the base class pressable button, which is also for HoloLens 1. And the second one is the pressable button HoloLens 2, which is inherited from the first one, right? So that we are going to use the pressable button for HoloLens 2. And you can see that there are a lot of properties for defining the press settings of the button, and you can see those new planes that got added, right? So those are the different planes, like the front touch plate and the back plate, different layers. I mean, when I say layers, the touchable layers, the physical layers which has been added to define how far a button can be pushed. All right, what is a pressable distance? What is the debounce? I mean, bouncing back once you release that your finger, how fast it will bounce back, and all those things will be defined. Yeah, you can see that the max push distance is defined by that blue button and blue plane in the back. So when you push the cube, it will go that far, right? So yeah, these are the different properties that you can actually define in here. So the release distance delta is basically something that defines, when it is treated as the press is released, and also the space mode should be in world because it's in the visual space of the 3D world, and the max push distance is basically how much you can push that button and things like that. So I'm gonna optimize these values so I can show it you a decent effect. That looks pretty much okay. Yeah, now you can see every time I change that distance, the plates will move. Basically, that's a visual cue for those particular values which when you modify it. So you can visualize it how far the button is going to go back, and how when it is treated as a touch and when it is treated as a release. Those are a lot of sort of things. And the return speed is nothing but it will define how fast it will bounce back. And then we have the events which are handled by this pressable button. Basically, when it touch begins, touch end, or button pressed and button release. It's one or the other, either touch or it's the click events. So we will handle that once we see how it is going to be fine. I mean, how it is going to be set. And in the case of this event that we received, if it is pointer, as I said, it will be the button process that will be triggered. And but the problem is the pressable button doesn't like or doesn't accept that particular event type. So we are going to move it back to its touch type, and we are going to handle those touch begin and touch end pretty soon, right? Now the key thing is that you need to put the moving button visuals, that is basically the same game object that needs to be acted as the button. So we are going to drag and drop the cube 2 there, so in order to declare that as the button. The next thing I'm going to do is, align that facing to the camera to by changing or turning it to 180-degree, right? So make sure that if we approach the plate from the front, the touchable plate from the front, because it won't trigger if you approach it from behind, and even if it touches, the events won't be triggered. So make sure that it is facing the user in this case, basically. So that's why we are turning it and facing the camera, so that front plate normal is always towards the camera. Now let's play and take a look at it. You can see the cube 2, and now you can see that uh, you know the button here. The thing is, it might not be, since it's right facing right next to us, it might not be easy to figure out the button being pressed. But you can see that action when the button is slowly going back when I move my finger, my fingertip, and touches that button. So you can see that, and when I release it, yeah, it's bouncing back. So so what I'm going to do is, in order to visualize this better, I'm going to put the game view and the scene view in stacking it up, so it's easy to see by looking at the scene view how the button bounces back and how the button press works and everything. So let me go and zoom into the button. Yeah, now you can see it. Let me give a better position. I'm gonna change the angle. So yeah, so that's basically we are going to press the button on the front, and the blue one is the back plate. So let me see. Yeah, that should do. So now look at the scene view when I press the button, right? So not the game view. So when I'm going to press it, you can see, yeah, you see that? That's basically the stress of how much I can press the button. And when the black plate touches that, the blue touchable plate, that's where it stops and it's bounce back. And you saw it, the bounce was pretty much smooth. So that's why I just changed it, the speed to double it, and you can see that you can see that, yeah, it's bouncing back pretty fast than the previous one. When I change it to 25, it's much, it's a slow bounce back, it's more natural. So you adjust all these settings, like I can push further if I, one second, I can, yeah, let me click on the, yep. Now you can see if I press it, yeah, it goes even further back, right? So but it won't leave the front plane. So that's, you need to keep a better ratio between the back plate and the front plate, where the cube ends up without the back and the front plate in its domain. It won't be a neat behavior if you do that. So yeah, keep a more, test it out, where play with the different values that you want to try it out and see which one suits you, or effect, it suits your effect. Now, if you look at it, yeah, you see, that's what I can do. Uh, yeah, so this is basically the pressable button from a visual perspective. So what we are going to do next is that I'm going to uh, basically handle those events. You can also look at those other other kind of properties which are available in the script. Most of them are actually for effects and highlighting those plates when the your finger comes closer and those kind of things. So you can play around with those, but these features which I just showed you are the defining features for this functionality, right? Let me stop the play. And another thing I wanted to show you is that the proximity finger, how the cursor changes. Last time I showed you. Okay, let me stack it up back. But in the meantime, what I showed you last time without adding that near intractable script was that when you point your finger, you were able to see a tether. But now you see, yeah, once you reach a particular point, yeah, you see a different kind of a cursor near that. And when you move out, you can still see the cursor. Yeah, in the red one, you will still be able to see it. No matter how close you get, you still see a tether, right? Yeah, you can see that. But in the case of this new one, where you have a near intractable added to it, if you get closer, it will change to a different cursor. See that? It will change from the tether to a different cursor. So that's another thing about the behavior of this near interaction touchable script. So what you noticed is that you were not able to see it moving actually, except for when I showed it in the scene view, right? Because it's not really, especially in this particular view in an editor, it's not really, that it's very subtle the moment. But maybe in the 3D view they'll be able to see it better. But still, it's always a good thing to give an audio feedback, an audio cue for the user when they start touching, start pushing and release the press. For that, what we are going to do is we are going to add an audio source first, so that we can handle the touch begin and touch end events, right? And this actually, I mean, this audio, and the values and all, the audio clips are, I'm taking it from the examples which are attached to this toolkit, which comes with the package itself. So it's not mine. I'm just borrowing it. So let's add the event for both touch and begin and end, and then add our cube, which contains the audio source. And then we'll use the audio source and use the play one shot. Then we need to put a clip, which because it takes one clip as the parameter, the audio source dot play one shot. It's a unity function, so there is nothing special about it. I'm just going to add a mrtk underscore, I think it's the button or push. I think it's button. Let me see. Yeah, it's the button press. So yeah, I just added the MRTK button press, and I think there is another one called the MRTK underscore button unpress. Okay, let me see. Underscore button unpress. Yeah, that's the one. So those are the two audio clips, right? So when a touch begin, the first one will play, and the next one, when I release it, the other one will play. Now let me stop it, and you can see that those scripts will be removed because I was in play mode. So I'm going to add those events again in the play mode. Actually, I need to add the audio source. Give me 1 second. So I just added those again, and be careful that if you are using a Bluetooth speaker, because I remember a long time back when I started, working on this, I had the issue where the sounds were not coming out because I was using a Bluetooth speaker. So I had to change my speaker in order to make sure that, when I say I had to switch to another speaker available, to make sure that I was able to hear that sound. So, yeah, right now I'm able to hear the sound when I'm pressing it, when I'm unpressing it, right? Yep. Okay. So let me stop. So this is basically all about the pressable button. Now there is one more thing that you can do. Apart from this audio cue, you can also give some visual cues like changing its color, changing the style and everything of the button by adding something called an intractable script, right? But I'm not, yeah, and the intractable script is like a very generic and highly functional one, which provides multiple input features like speech, controller types, and it can change the theme of the game object based on different kind of inputs. But since I haven't covered that, those it's better to cover this intractable script later after I cover the speech and other kind of inputs, right? So for now I'm going to leave it aside, and we will cover it once in a later phase. Right. For now, yeah, this is basically everything about the pressable button, and now we are going to see, how we can manipulate an object through using the grab pointer. So what you saw right now was the poke pointer in action. You saw how it changes, how you can press on it, and uh, how the pointer changes and everything based on the shader and everything, right? But at the end of the day, it was a poke pointer which was figuring out the near interaction touchable script and making this all possible triggering the events and everything. All right, let's take a look into the grab pointer. Now we are going to see a manipulation of an object by, let's create a new object. uh, Oops, let me delete that one. Let me create a new cube. All right, 3D object. Yeah, there you go. So right now, let me change it to um, yeah. Let's consider it as a square football, right? Basically, I'm gonna name it as a football, but uh, basically it is in this case here it's a square football. What we are going to do is we are going to use this object in order to demo our manipulation with the grab pointer, with the help of seeing grab pointer in action and how manipulation handler puts that to use. So I'm gonna change the scalability to half of what it is right now, so we can see when we scale it up and scale it down and everything, right? So let me put it in yeah, in the proper way, and remove the green one now that we are done with it. Remove the red. Yep. So let me add the material. We can use the same material. We don't need. So again, this is going to be the standard Mixed Reality Toolkit standard shader, which I just applied. And let's go ahead and the near interaction grabbable. There you go. So if you open that, there's only basically one property which we will see what that show tether means. It's nothing but it's very evident from the example itself that it will simply show the tethering. And let me add the manipulation handler. So this manipulation handler script is basically what we use to actually manipulate that object, right? Now remember, the manipulation handlers is used for both far interaction as well as for near interaction. It just makes use of the pointer, in this case the grab pointer, which is available to see if it is near, if it's and it's grabbable and all those things. That's all. When it is in the near proximity. So. Otherwise, it allows both one hand and two hand modifications, and it allows far manipulation too, right? In that case, it won't rely on the near grabbable pointer or grab pointer. So you can turn on or turn off according to your requirements. Now, if you look at the property, the host transform, that's basically what this manipulation handler used to change, it for the manipulation purpose. So we are going to add our football as a feature. Basically, that's the object we want to manipulate. I'll also show you later how we can manipulate another object using this particular script on a different object. It creates some different purpose and different effect. So it also allows different kind of manipulation. You can choose between scale, rotate, and move, or a different combinations of it, or all of it. Right now I have chosen all of them so that I can show you both moving, scaling, and rotation with it. Right, and then you can see in which axis it want to be rotated, and it also show you the rotation behavior of the object and all those things. And you can also restrict them from rotating or moving from in a particular axis. You can show, say, okay, I want to use only x-axis, like that. So you have all those choices. And then what you have is the smoothing effect. Basically, that's nothing but it is used for avoiding jerky movements. And then you have the manipulation events, like manipulation started, ended, and everything. We are going to use that also for the same way we used in the poke pointer, where to give the audio cues. So when a manipulation starts and when a manipulation ends, right? So let's see how this is gonna play. 1 second. Yep, that's the one. Now you can see that right in front of me, everything is fine. Now you see this is one hand operation, and right now I have enabled the far interaction of far manipulation. So look at, if you want to see, look at that the transform positions. Right now we have kept everything at 0, and only the z-axis is a bit higher. So when I played, you can see those positions and rotations and scaling and everything changing. So this is basically I point it and I click on it, so that's a click event. And then I just uh, moved with it. So here you can see this is the near interaction. I'm just moving it around when I'm in near position. So this is where the near interaction graph will which will tell, okay, yeah, this also allows near interactions, right? So now what I'm going to do is a two-hand interaction, right? For, let's say, scaling it. So what I'm going to do is, right now I am just using the since I'm moving in tandem, it's going to just move around. Now I'm using my left hand to hold one end, and the right hand to hold the other end. Right now you can see the scaling part, right? So I'm scaling it up. You can see the right transform. So yeah, and now I'm scaling it down as well as rotating, because my I just toggled my left hand. That's why my left hand is not moving. So I'm just using my mouse to move through the move the right hand. But you can, in reality, you'll be able to use both your hands to really remove scale it up and manipulate that object really well. Now you can see that short tether when when manipulation, when it comes to the near interaction. So before, when I showed it to you, you were not able to see that tether. Now if I'm doing it, yeah, there is no tether. But when I start manipulating, 1 second. Yep, there you go. Now I'm manipulating. You can see that tether, right? Even still now, it's a different tether which is attached to my fingers. So that's basically the use of that short tether property while manipulating, right? Otherwise, that particular tether won't be enabled by default. So now, let's say I'm not allowing for manipulation, right? So what happens? See, I can just move my hand around, but nothing is going to happen. You can look at the transform there. It's not going to change, right? It will just it's going to stay there. But in the close one, if you look at it, 1 second. Yeah, I just need to. There you go. So in the near interaction, I can manipulate it, right? But in the far interactions, I won't be able to manipulate it. So that's basically that particular checkbox is used for. Yeah, there you go. So if I the next thing is like what we are going to do is let's stop that and then add our audio cues by handling the on manipulation started and on manipulation ended. Now I'm using this just for the demo for showing how to use those events, but there is no restriction that you can use it only for as a audio cue. So even though I'm using it just for that, you can handle it. While if you want to do something else based on your requirements, definitely go ahead. You're free to go ahead and do it. Now let me add an audio source just like last time. Nothing different. Audio source, play one shot, and same thing here. All right, and then now I need to add the clip. Uh, Let me see. There you go. And I need to say MRTK underscore. I think it's the uh, move event. Yeah, move start. Yep. And the next one, we can see the MRTK move end. I think, yeah, there you go. All right. So that's now again, I don't know if you're able to hear these small audio cue voices, but when I play it, I'm able to hear those when I not now. Yeah, now I can, when I the moment I start moving, I can hear those voices, and when I stop it, also I can hear those audio cues. So that's basically about the poke pointer and the grab pointer and its applications with this touch and the pressable button and the manipulation handler. Now, if you want to take a look at those manipulation handlers, because it's pretty straightforward, you can go ahead and take a look at it. And if you got any more questions or anything related to that, you can ask away. It works in a simple fashion, using a state machine in order to update the state of the object based on the events it receives, and that's basically the pointer events as well as the focus changed events that we have seen before. Right now, the next thing that we are going to see, and the final one in this session, is basically a bounding box. So just like the way we gave audio cues, now what we are going to do is give the visual cues to show the user that a particular object can be manipulated, or like rotation and scaling specifically, because the bounding box is a script that you can use to attach to an object, and what it does is like it will let you rotate and scale the object, not move the object. Right. So I'm gonna add this bounding box right now, and also another thing is like you can combine this bounding box along with the manipulation handler if you also want to move around the object and also at the same time give a visual cue. Now it comes with a lot of properties there, right? Another thing is like, yeah, the near interaction grabbable. It's not, even if without that, this bounding box will work. That's another thing. And the target object is one of the properties. It contains a lot of properties, but the target object is basically it specifies which object will get transformed by the bounding box manipulation, right? If nothing is set, it will just take the owner object, which is wherever the script is attached to. So right now I'm going to assign to the target object our football. And the next one is the bounce override. It basically sets the box collider. It sets a box collider from the object for bounce computation. So be careful if you have any, a complex objects like a humanoid object or something. In that case, it might not, the computation might not work as expected. So in that case, you might have to manually set a box, right? It's a pretty straightforward thing that you can set. It's kind of like a box will appear, a box collider will appear around a humanoid object. So that's another thing that you need to note when it comes to this bounce override. Other things are pretty straightforward. How to calculate this method and everything. So basically render over the collider itself. So I will also show you when we demo it, different changes that happens to this the bounding box based on the user inputs. So that's another thing. Yeah, apart from scaling and proximity, I mean, apart from scaling and rotation, another thing that it can do is handle user inputs like proximities when a user is closer. Now what I'm going to do is assign materials, in order to make sure that different materials to this, the handles. So a bounding box is going to display the handles with which it tells the user that, hey, you can manipulate it. So I'm going to set up those materials and the prefabs so that it will look good. So this is there are different styles you can apply. You can have even your own. This is basically again taking it from the, I think it's coming from the training set. I mean the example set which comes with the toolkit itself. So I'm just using those uh, to give it a HoloLens 2 like style. So let me select um, the slate prefab. Okay, and then rotation handle. So what happens? Yep, MRTK. I think mounting box rotate handle. Yeah, that's the one. Um, and I need to remove the default prefab to a standard. Yeah, prefab object. Right, and the scaling and everything, all those values, look, I'm going to keep it as a default one. I'm not going to change any of them, but you can experiment it because there are a lot of properties to maintain, and most of them are self-explanatory. So we won't have enough time to go through all of them. And another thing is that the proximity related thing, you can see that the proximity effect is active. That is the one thing that I will demo what happens when that is turned on, right? So let's go ahead and play. So now you can see when it's playing that it automatically created a different script called a transform scale, right? And now you also can see those bounding boxes, the white corners, as well as that the ones in the middle, edges. So yeah, when I'm getting close to it, I'm not really sure. I think I chose a wrong color to go with white. But yeah, I believe you can see that all those corners. So I can move around. That is because I have the manipulation handler script attached to it, right? That's the reason I'm able to move around. But when I'm seeing it, you can see that, yeah, in the close one, also I'm just doing the position changes. So I'm gonna stop it now. And what I'm going to do is, remove that manipulation handler here, right? So yep, let's take it out. So we'll see the actual effect of the bounding box. Okay, let's play again. All right, now you can see it automatically created that transform scale, and it will let me rotate and scale, this particular box even without the manipulation handler. And but the only thing is, in this case, I won't be able to, move it around. So let me grab that handle first. But when you try it in actual HoloLens, it's pretty easy compared to doing it from this editor or an emulator. So now you can see I can scale it around, and I am right now. If I hold it from the corner, yeah, I'm scaling it around. Now, what I'm going to do is I'm going to grab it and rotate it, holding the middle one in the edges. Now you can see that, yeah. But in both cases, you can also see a tether attached to my index finger. Now let me see. Yeah, I'm going to rotate it from both ways. Now, the interesting thing, as I mentioned it before, about the bounding box is that it does not really need that near interaction grabbable scripts, right? So I just removed it, and I'm going to do it without those near interaction grabbables, because it uses another script called the transform scale in order to, make that rotation and scale possible. So we are not you don't, if you only want those two features, and in that case you don't really have to use the near interaction grabbable script actually. And the interesting part is that you can do both. It supports both far and near interactions of scaling and rotation. So let's take a look at this script. In that one, you can see that it uses the focus handler, and the focus changed and the source state changed, right? The source state change is used for detecting new state changes, right? When there is a new input source is detected or one is lost. So that's where it actually detects if there is some hover effect and those kind of things. In this case, it's handling the on focus changed, and in the mono behavior also you can see how it works, with the proximity effects and all those things. Now, if you look at that definition, you can see that it accepts the rotate and scale, and draws a cube around the object to visualize the possibility of a user trigger transform manipulation, and also allows the near and far interaction manipulation too. Right. So that's basically about the bounding box. Now, I wanted to show you two more small features. One is that proximity. I don't know if you noticed it before, and another one is that when you target a different object from the current object, how you can do that, right? So that's another thing that I want to show you. Now let's go back to our Unity, and let me show what happens when we turn on the proximity active in the bounding box. Okay, let's turn on the proximity effect active here, and then we will see that we will see the effect actually. So what actually happens is, like previously when I turned it off, you were able to see immediately that the cube and the corner handles in the object, right? But now you won't be able to see that because I have turned on this proximity effect. The what how it works is, like, only when the user gets closer to that object, or your finger gets closer to that object, or your pointer, if it's not a finger, if it's your pointer gets closer to that object and its corners, that's when each of those handles will become visible, right? Now, it, in this particular demo, I should have, if you, especially if you choose a different shape object like a sphere or a humanoid, or something that is not a primitive box, basically. Because I think in this demo I shouldn't have chose a box, because the reason is the collider and the handles will hug each other, which will make it a bit difficult for you to notice that effect. But otherwise, where there'll be some empty space between the actual box display as well as the actual figure that that needs to be manipulated. So in that case, when you point at it, and you will be able to see a small box and that corner getting more evident. All right, let me show you that. Let's click play. And now you can see there is no box, right? Now, but when I get closer also, now when my cursor gets closer, you can see that white, yeah, there, where my finger is closer, you can see, uh, let me point it out. There you go. So now you can see that, yeah, every time I move closer to the corner or that middle edge, you are able to see that, right? So that's basically that proximity effect. And then you can actually go ahead, you can grab it and scale it like that by holding the corner. The only thing is that now it's not, if your object, you don't want to kill the visuals by always showing an object around it, but only when user intends to manipulate it, or when user gets closer to it, this would be a neat way to show it to the user that, okay, I am manipulatable, right? Or I can be scaled or rotated around. Now, the next one I want to show you, and the final one in this session I want to show you, is how to retarget to a different object. So now we have added our script of bounding box to our football, but I have changed its target object to the cube one. So see how it's going to change, right, in the scene where I am manipulating the cube object, right? Um, Let me grab it, and you can see, yeah, see that So when I'm pulling on the green, it's actually the red one which is actually getting manipulated, right? So this is basically what happens. So in a real world scenario or in your actual application, let's say you have a real, I mean, a big figure, like a actual real life humanoid figure in the scene, right? But you don't want the actual user to always go back and manipulate on that object, but still you can create a replica of it, like a small model of it, which is near to the user. Let's say something is on the table, right? And then what happens is like you can use the user can actually use the small replica figure on the table to scale, the actual real figure on the in the scene. It's kind of like a remote, right, where you use one object, scale it around to actually manipulate another object. So that's a cool feature, I think, which can be put to multiple different purposes. So that's basically all about bounding boxes. You can go ahead and play around with all those properties and how see how kind of what kind of visuals you can create. Now, before winding up this session, I want to point out two more things. One is that the POC pointer and the grab pointer, essentially the near pointers, are available for HoloLens 2 only, not for any other kind of devices. That's the first thing, right? So be careful about which device you target and what kind of effect that you use. The second thing is that when you are using those sphere casting for the pointers, uh, the spatial understanding layer, right, or the spatial awareness layer is excluded from it, right? So it doesn't, because just for the performance savings. The reason is that it's going to be very costly when you do scan on the entire spatial mesh for this purpose, right? So just be careful. If you want it, you can enable it manually. Well, that's pretty much everything about it. And next session, we are going to see about a speech input. And if you've got any questions or comments and any feedback, feel free to let me know. As usual, I'll respond to that, as soon as possible and to the best of my capability. Until then, see ya. Bye.